Hello friends, this video on p-block elements part 6 is brought to you by examfear.com. No more fear from exam. So let's start with the metallic character now. So if you see the trend in the metallic character, we have learned this also. If you go down the group, the metallic character increase. This side also it increase. So if you see here, the brown ones, the gray ones are my metalloids. Let's talk about the metal first. These are my metals actually, aluminum, gallium, tin, all these are metals, right? And then we have metalloids in the brown, and then we have non-metals also. So if you see, you can say that, for example, in this group you see, this is non-metal, then metalloids, and then metal. So if you see here, I can say that the metallic character is increasing, correct? So if you go down the group, the metallic character increase. That's what you can see here. Non-metal, then metalloid, then metal. Here also non-metal, metalloid, metal. Non-metal, metalloid, metal. All halogens. And these are all noble gas. You can ignore this part, but if you see the group 13, 14, 15, 16, it is metalloid, then metals. Non-metal, metalloids, metal. So the metallic character is increasing as we go down the. So chemically, as we know, what are metals? Metals are electron donating. So there's an electron, it donates the electron, right? And non-metals are, there is electron, it accepts the electron. That's the difference, right? So metals, as you know, they are someone who donates electron. For example, sodium will give electron, will become Na plus and will give electron. As the chlorine will take electron and become Cl minus. Correct? So metals are nothing but they give an electron, and non-metals are something which takes electron. That is the only difference chemically, right? The properties are different, but that's the main basic difference between metal and non-metal. So if you go down the group, what happens is the size increase, the effective nuclear charge decrease. So they have more tendency to give electron. So the metallic character increases. But if you see here, right, the top few elements, the size is less. If you, for example, if you compare, let's suppose carbon and germanium, the carbon size is less, germanium size is more. So germanium has more tendency to give electron because these electrons are not held tightly with the nucleus. So it is little metallic in character. But carbon, they have less tendency to give electron. In fact, they want to get electron. So they are non-metals. It's all about tendency to give and take electron. The size increase, they'll have more tendency to give electron. Why? Because the electrons, outermost electrons are not much in control. So it's all about being in control. If the nucleus can control these electrons and they have more power to attract electron, they become non-metal. If the nucleus are not powerful enough and their domain is, their size is big, they are not able to control this electron, this electron will go out and will mix with some other. So that is how it is, right? So it's all about how effective the nucleus is holding the electron. If the nucleus is holding the electron tightly and it has more power to attract other electrons, it is non-metals. If it is not holding tightly, for example in this case germanium, it goes out and it becomes non-metal. And sometimes there are other reasons for it to become non-metal. For example, sodium, it has only one extra electron. So the nucleus itself wants that electron to go off to become stable, right? So there is a selfish desire of sodium to give an electron to become stable, and that's why it is also a metal, because sodium easily gives an electron to become stable, correct? So this is the whole story why some metals are strong, because some metals, for example sodium, the moment it gives electron becomes stable, so it has selfish desire to become stable and selfish desire to give electrons. So sodium is a very strong metal. But if we talk about these metals, they are weak metals because they don't have selfish desire to give electron, right? Because they won't become stable, but they don't have choice because they are big and some other strong non-metals is pulling the electron from them, right? So they are not very strong metals. They are not very eager to give electron, but somehow people are snatching it from them, right? So sodium is eager to give electrons, so sodium is a strong metal. These guys are not eager to give electron, but other non-metals are snatching electrons from them, so they are not that strong metals. So that's how you see the chemistry from that point of view, right? If you understand the electrons, it all behaves like human beings, right? They are mean, They want to be stable and they can do anything to become stable. The only target in their life is to attain stability. Right? Everybody, for example, chlorine, they want to become stable, they'll try to become stable. And sometimes you will see that, for example, we'll talk about this, that some compounds forms BX3, but BY3 is not formed. Why we'll talk about that also. We'll see that it's not only about taking and giving electron, it's all about the compatibility of size also, right? Whether the size is stable. We'll talk about all this thing, but just understand that in chemical world, the key mantra is stability. Whatever the metallic, non-metallic character a particular element shows, it's all because of hungerness to attain stable condition in their life. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.